Hello. So this talk is called Active Research on Advanced Debugging Tools. I'm Steven and this is Thomas. We are researchers at Inria in the RMoD team. And we are going to talk about not the research, about okay, so we do research on debugging, and from that research, we produce debugging tools. And what we are going to present today are the prototypes of the debugging tools which are developed from that research. So what are advanced debugging tools? So in the context of our research, we have the fact that debuggers are very hard to construct, and they are hard to understand and to use by developers. And if you look at the tools produced by research works, you often have one specific tool that will help you solve one specific problem when you debug. So our goal is to help you to give you tools to build your own debugging tools for your own problems. So instead of having a lot of different solutions and having to use lots of different tools, you have one main tool from which you build your own specific debugging tools. So why would you need to build your own debugging tools instead of using what is already existing? The thing is, what we want is that to provide you means to cope with the problems that you have as every day when you develop, to help you choose the right level of abstraction and to move beyond those levels of abstraction. For example, when you debug, sometimes you will need very low level information from, for example, the debugging stack. And sometimes you need to have more abstract informations like information about the abstract syntax tree when you are debugging your program. And you need to adapt that level of abstraction when you debug, like when you try to narrow down the scope of what you are looking for. And sometimes you need to go back and have a more general view. And for that, we are going to present Sindarin, which is an API to script the Faro debugger. Which is API, you can control the debugger and build specific debugging scripts, and also build tools using those debugging scripts. So we are going to show you demos of the prototypes and applications of that scripting API, which are a scriptable debugger, a tool for testing, which is named PowerAssert, and we will also explain how we will use Sindarin to provide infrared means to customize the Faro debugger. So Thomas is gonna show you a demo of the debugger.
Yep, that's my cue. Hello. Yep. Okay, so the idea of the first application of Sindarin is to have some debugger you can script. So on the left is you, and on the right is what you want to do, the execution you want to debug. So normally, right now you have a debugger, you click buttons, you look at things. It works fine, sometimes. But now what I'm presenting is an alternative way to interact with the execution. So we are programmers, so sometimes we need a user interface to discover features, and other times we need scripting to make something powerful out of it. And that's what was missing from the current debugger, and that's what we are adding right now. So this is a warm-up example. Here we go. So in this example, I'm a gold digger. I'm looking for gold. Debug. Now that's interesting. Nice, no stack. Okay, well, whatever. So I'm here at the start of my execution. I set a breakpoint somewhere, and I'm like, oh, I'm looking for gold. So this is a rock, not interesting. A rock, not interesting, not interesting. More rock, more rocks, and gold. Woo. So you've explored manually your execution, finding an interesting point. And now, usually what you want to do is you want to retry the execution with something different. You changed a bit of code. You try to find out how the execution works so that you can debug it. Now, the issue is that, do you remember which steps I did to reach the goal? No, you don't. Yeah. So I'm here, and yep, I have to check my cheat sheet. So the idea is that I don't want to click all the buttons, because maybe I clicked like 60 buttons in a row, and no one wants to do that more than once. So what I can do is here is this. Boom, Sindarin. Oh, this is spoiler. There we go. And this window is the scriptable version of the same debugger that you see on the left. So if I get my cheat sheet, no, not this one. There we go. There we go. So you can write a script that looks like this. Thank you. And as you probably guessed, it does the right thing. And if I synchronize my debugger again, we are in a weird place. Demo effect. Awesome. Let's give it one more shot. And this is not the right amount of steps. There we go. Okay, cool. So it's essentially doing the steps. That was the warm example. So obviously what I showed, this is the demo I showed. Obviously what I showed is the very, very basic. It's just doing steps. But you can do much more, because the API allows you to do much more. So step over, proceed. And this one you may not know, skip. So you're about to send a message, but you really don't want to send it because you know it's going to break something. And you're like, continue the execution, but don't do this. Well, you can do skip. It does that. You can get information about the context. So which sender am I? Which receiver? What are the arguments? Where am I in the method? This kind of stuff. You can set breakpoints. You can set what should happen when the breakpoint is hit. You can get the AST nodes you're currently executing. And you have a bunch of helpers. So message receiver is like when you're about to send a message, what is the receiver? So I can like maybe do some conditional thing. Do I want to step into it or not? All the good stuff and more. Because obviously not everything is on this slide. And time for the next demo, something a bit more complicated. So in this demo, let's quit this, let's quit that. So in this demo, I have a very simple iteration loop. I iterate over this collection, and I count all the items. Very simple. Now, usually you go something like this, step through, and then you want to go in the iteration itself, because that's the interesting part. And now imagine you want to go to the next iteration. Well, do something like this, and then maybe, I don't know, like you're in the code of the collection all of a sudden, so you have to find, I need to step more, and this is still not interesting code because I'm guessing the code of array works, and it's not the cause of my problem. So I step, and I step, and I step, and I step. Whew, and here we are at the next iteration of 3. Sindarin can make this quicker. So by the same token, I'm going to open Sindarin script, check out my cheat sheet. And this time I'm going to explain the script a bit more, because there's more to it. Okay, so what I'm doing here in the script is that I'm saying, oh, keep the current context I'm in a variable. So let's do that. Then I do, while I'm in this context, I want to step. So essentially, I want to leave the current iteration. So let's do that. And then I want to, whenever the receiver is a kind of array, so in the code of the do method, I want to step. So, and this will stop until I'm no longer on the array. And if I sync my debugger again and demo works, I'm back in the block, but this time, next iteration. And if I do this again, if I execute the whole script, and here we go. Next iteration. One click, bam. So that was that. And this is the script I just shown, so skip. And now for my last trick, I'm going to step until an execution is about to happen, and then skip it because I know where it's going and I'm not interested in it. I just want the execution to continue. I know this part of the code is bogus. I will fix it later. Just let me go further. So remove this, remove that, launch the demo. And there we go. So this is just the execution in question is just a bunch of methods that call other method that call other method. At some point, there is an exception that's thrown. So same token, I open my trusty scriptable debugger, remove this, check my cheat sheet. So what I'm about to do is I have a big while loop here. And while this condition is false, I will step. And this condition is I need to be about to execute a message. So the node I'm currently executing must be a message. And the message selector must be a signal. And the message receiver must be a subclass of exception. If I do this, and I sync my debugger, magic. Whoa, I'm here in an exception. And now it's not done because I want, if I step here, it will actually throw the exception, and I don't want that to happen. So I can skip the message then. If I sync again, I'm just after the exception, and I can keep going. Ooh. Alrighty. So no, something with a bit different, but still using Sindarin, PowerAssert. So the idea is that for those of us that saw the presentation, I gave it the Innovation Awards. That's it. The idea is that you have assertion in tests, and they work fine, and sometimes they fail. And when they fail, you maybe want more than an exception and a debugger opening. You want a bit more about what happened for the assertion to fail. Demonstration. So this goes, and I need this one. So this is a very, very simple test. I have a bunch of divisors of 60 in an array. And then my assertion is that if I divide 60 by one of these divisors picked at random, it's supposed to be an integer. And you probably guessed the problem is that there's a 0 here. So whenever I take the random, 0, divide by 0, broken. So obviously it's going to work a few times, and so I'm going to run the test like 15 times to get a failure, so that it gets interesting. Yeah, please fail. Thank you. So this is your normal debugger, which essentially says, well, this thing was worth 0, so divide by 0, bad. Thank you. And this is PowerAssert. So here you can see the assertion I made. 60 divided by stuff is an integer. And here you have a record of the AST nodes that were evaluated during the assertion and the value they had. So 60 was worth 60, okay, big surprise. The array was worth the array, again, surprise. The size of the array was worth 13, okay? And then the at random returned 1, which is why it picked a 0, which is why it broke. The additional information you get here is the value of the sub-expressions, because usually you get a pretty good idea of the value of the whole expression, but in this tool you can get the sub-expressions. And now, if I were to replay the test, right here, obviously it's going to work because it's a bit random. So what I want to do to debug this thing is I want to replay the test with these values that led to the problem and debug that, which I can do. So this is the PowerAssert Replayer. Here you can find the assertion again. And I'm at the start of the assertion. It's skipped a few non-interesting nodes like the 60. Don't worry about that. So I'm about to do the call to size. And if I do step over replay, it's going to reuse the same value. But in the case of size, you see 13. In the case of size, it's not really interesting because it's deterministic, so whatever. But if I do replay on the at random call, and I get 1. And if I restart the test and do this again, I get 1. I get 1 every single time. And that's the point. If I do a normal step over, just to see, I get some other value. All right. Yeah, so this is the demo I just did. So skip, skip, skip. And this is the script that's performing the actual recording. So as you can see, it's quite short. I'm essentially doing, I create a debugger on the execution of the assertion. I create a collection. I just keep in mind the block node, so I only execute the block node itself. And then I have a while loop that steps the block, and then every time I'm like, oh, I'm on this node, I step, oh, it was worth this. I store, step, node, store, step, node, store, etc., etc., and then I return the collection. Like, super simple. Of course, there are some cases, complicated cases I'm not showing here, but you get the point. Yeah, and these were a few examples, but you really have a lot of power with Sindarin as a whole. So you can really, the limit is your imagination, if I can use this cliche. So for example, here are a few neat things you could do with Sindarin, like step until a temporary variable with the name you give is assigned a new value. You can do that. You basically step until you're on a node that is a temporary variable assignment. You can even check that the value is this value you provide, your convenience. Then you could actually skip the assignment itself and put another value. You do you. This is a simpler one. You can step until the current context returns. So essentially finish the method, which can come in handy when you are stepping through a lot of methods. And you can do some logging. So like the PowerAssert records the value of nodes, but you can record anything. So in the while loop, I can say, well, I want the messages that were sent, and you add them to the collection. And you can add a condition that, oh, I only want to log when the receiver is that particular object I'm interested in. So really, and oh yeah, I have one last thing. Right now, I'm only debugging one execution. But since I have a scriptable debugger, I can have 2 executions at the same time. And for example, if you have the same test but that works on one version of the code and that doesn't on a slightly different version of the code, you may want to step both execution in parallel until they diverge. You find the difference, and then you're on a good way to find the bug and solve it. Yeah, and I'm gonna, yeah, and more, because the limit is your imagination. And I'm gonna give the talk back to Steven.
Okay, so you have seen that you can write scripts with Sindarin to talk to your debugger and establish a relationship between you two. And Thomas just showed you the debugger and the Sindarin scripting API as a separate tools. But what we're going to do in far right is to have only Sindarin to talk to the debugging model and to have the real Faro debugger using Sindarin to offer you the possibilities, the same possibilities that Sindarin does. So basically, with Faro, the future Faro debugger, you will be able to use all that power from the tools, the standard tools. And so the question is, do we have to always write the scripts each time we want to debug some specific things? So I will show you how you can customize very easily the debugger with a Sindarin script. So I will just write debug some random code. Okay, so I am debugging code. And imagine you need to write a Sindarin script. But the thing is that you can open the Sindarin debugger and write everything by hand. For example, let's say I like this script. So what you can do now is define new commands directly from the debugger. So you will give your command a name. It will be my command, and you will give it an icon if you wish. I will leave the abstract icon, but you have access to all the icons from Faro. And then you write your script into the interface, and you create your button. And you see that you have your new command which appears in the debugger here. And if you click on that button, it executes your command. So it will not work because I put a script dedicated to another debugging session, but I will show you a simple example. So in that interface, you interact with the debugger by using a dbj instance, which refers to the Sindarin debugger. So I create this method, this action, it's here, and then if I use it, it steps over 2 times, and I can do it again, and it will probably fail because the execution is finished. And if you open again a debugger, your actions are still there. So you can build scripts and reuse them very easily in your debugging session. And if you wish, you can also remove all of them. Of course, this is just a prototype, so the tooling is improving. Okay, so this is a demo. So what we want to do in the future with Sindarin is to offer you more and more tools based on our research results. For example, we want to add an option to record automatically the steps that you do in the debugging sessions so that you can automatically generate a script that will help you reproduce your bug. We want to add object-centric debugging tools to the Sindarin API, and we also have a nice way with Sindarin to navigate an execution by stepping and to automatically capture objects to which we will apply the object-centric operators. Because if you saw my presentation yesterday, each time I want to send to set an object-specific breakpoint, I have to open an inspector on my object, and you don't always have the possibility to have an inspector, especially if you want to instrument a temporary object. But with Sindarin, as you can control the execution, you can find the right moment where you find your object to debug. And if it gives you ideas, of course, you can come to us and tell us about it. So thank you. You can load the prototype tools on GitHub. And if you're interested to know more about the API, you can also check our paper, which will soon be published, which describes the API in details. Thank you. You have questions?
This guy here.
Oops. I just wondering what will happen if in the script I will have an error, an exception in the debugger script.
In this, well, it opens a debugger on the debugger in this case. It's
it's integrated in the tool, so you can debug your script and correct the script. But of course, if you started stepping over and stuff, you cannot just re-execute safely your work script because it will not start at the same point. But you can debug the script.
Okay, thanks.
Okay, cool. Thank you.